welcome to Physics Form 4. I am your teacher, Mr. Nderitu. I'm taking you through the first topic in Form 4, known as the lenses. So far, we have looked at lenses, we have looked at properties or parts, key parts of lenses, and today I want us to look at what we call image properties of lenses. And to start us off, we are going to start with what we call a converging lens. And we look at properties or how different images behave when they are put at different points. So the first one, we start when the object is at infinity. A, object at infinity. For example, the rays from the sun, they come and hit what we call a convex lens. So for that example, let us assume these are the rays that are coming from infinity. Then we know that rays that are close and parallel, they always converge towards F. There we have it. So they converge to meet at this F. Therefore, the first property of images formed when the object is at infinity, number one, they form at F. The image forms at F. Number two, it is real. Why? Because it is made of real rays. Number three, it is inverted. The reason it is inverted is because you see the upper one came to the lower side, the lower ray came to the upper side. Finally, we say that it is diminished, or diminished means it becomes smaller than the original object. Some application of this application, we find it in number one, in telescope. Number two, we find it in solar concentrators. Number two, what if the object is placed beyond 2F or in front of 2F? So let me place an arrow there, and then we see how the properties behave. So let me put a small arrow just next to 2F. Then I'm going to use the rules that we learned about images. For example, the one that says that the ray is close and parallel to the principal axis, then the ray comes through F. So there it is, through F. Another law was telling us a ray through the optical center is undeviated. So I just passed it through the optical center. And as you can see, the image is formed here. This is our image. And which are some of the properties that we can see? Number one, I can see that the image is real. Why? Since it is formed using real rays. It is inverted. It is formed between F and 2F. Another property we can see, it is also diminished, a bit small. It is diminished when you compare to the original. This was a bit long, this is a bit short. Application of this, where do we find such setups? Number one, we can find it in a camera. Number two, a human eye. Next, we look at another property. What if the object is placed at 2F? Object number C, object at 2F, exactly at 2F. And we want to see how the images will be formed. So allow me to draw an arrow at 2F, just a short arrow there. Using the first rule, a ray that is parallel and crossed comes out through F. Another rule that I can use, through the optical center, passes straight. So here we have it here. Through the optical center is undeviated. And we can see the image is forming exactly at the other 2f on the other side. So properties of this image is number 1, the image is formed at 2f. So if it was in this 2f, it will come to the other 2f. Another property, it is real. Inverted. Inverted means upside down. The arrow was facing up, now it's down. Number 2, it is same size. And some of the application of such a setup would be application. Number 1, it is applied in terrestrial telescopes. That's a place where you can find such a setup. Number D, we look at what if the image is between 2f and f. What happens if the image is between 2f and f? So allow me to draw a small arrow between 2f and f so that we can look at the behavior of that object. How is the image? So the first one is the simplest. A ray that is parallel comes out through f. There we have it. And the other one says that a ray through the optical center is undeviated. So allow me to draw that ray through the optical center, which is said to be undeviated. Properties. Number 1, the image is formed beyond 2f, yani past 2f. As you can see, it has gone past 2f. Number 2, it is real. Inverted. It is also magnified, meaning it is bigger than the original one. Finally, we look at application. Application, it is used in projectors. Projectors. It can also be used in photographic enlargers. Enlargers, the ones that enlarge photography and what have you. Next, we go to an image, number E, an image or an object exactly at F. So we place a small arrow here at F. Just have it there. So the first one goes parallel, it comes through F. So there we have it. The other one goes through the optical center and it is undeviated. And as you can see, the rays are not meeting. So this one we say it meets at infinity. Infinity. In fact, it's almost the opposite of the first one. So properties of this image. Number 1, we say it meets at infinity. Infinity. Number 2, it is real. Number 3, it is inverted. Number 4, we say that it is enlarged or magnified, enlarged. And application, number 1, we can find it in spotlights. Number 2, another application, it is found in searchlights. For example, lights that are used in the prisons where they have you under a spotlight in case you try to escape. Finally, what if we place the object, number F, object, we place it between F and optical center. So in between here. There we have it, somewhere here. Allow me to draw a small arrow. So number 1, the rules are still there. A ray that is close and parallel to the principal axis goes through F. A ray that is to the optical center is undeviated. But as you can see, these lines are not parallel, so they cannot meet at infinity. So we push them backwards a little bit. There we have it. And they meet somewhere here, though they are dotted. So number 1, the image is number 1, virtual. That's why it has dots. Number 2, it is magnified. Number 3, it is enlarged. No, that is also magnified. It is upright. Then it is formed behind the lens, or the other side of the lens, behind, or we can substitute that with maybe saying the fact that it is virtual, then we can have it as okay. Next we have uses, application of such a setup. They are used in magnifying glass, magnifying lens or glass. Finally, we find them in microscopes. So these are the image properties of different setups. We have been working with converging lens. Next time we are just going to look at a diverging. The good thing about diverging, it is the same for all the setups. So tukisoma moja, or once we do one, then we are okay with the rest. So have this in mind. You can always sketch them in case you forget how the properties of the images behave at different points. Thank you, and let us meet next time.